One of the hottest topics in STEM today is nuclear fusion. And when I say hot, I mean like 40 million degrees Kelvin. Many people have heard of nuclear fusion, but still have questions. What exactly is fusion? Why should we use it? Why don't we already use it? My hope today is to answer these questions and shed some light on this potentially game-changing energy source. First, what is fusion? Fusion is the process of joining or fusing hydrogen atoms to make helium atoms, which release huge amounts of energy. This occurs naturally in our sun and other stars. For years, scientists have wanted to replicate this on Earth, using two isotopes of hydrogen called deuterium and tritium, which are less stable, to produce a stable helium atom and one neutron. Combining two unstable atoms into one stable atom produces tons of energy because the energy that can be released through nuclear reactions is due to the amount of energy it takes to hold a nucleus together. So why use fusion? Fusion, if controlled, can provide a solution to the world's energy crisis by being a perpetual source of energy that creates no waste or pollutions and no risk of nuclear accidents. So, in essence, a clean, renewable energy source. So, why don't we already use it? Well, there are a few kinks we have still to work out. For fusion to happen, we have to force atoms' nuclei to be incredibly close together, which proves very difficult because the protons in the nuclei repel each other. This requires a ton of energy, specifically heat energy, equivalent to 40 million degrees Kelvin. Now, at 40 million degrees Kelvin, the atoms turn to plasma, which is positively charged. The question then becomes, how do we contain this plasma? In the project labeled JET in Oxford, England, scientists are using a machine called the tokamak to create a magnetic field to cage the plasma. However, when plasma leaks, the reaction won't proceed. Another technique at the National Ignition Facility in California is using a powerful laser which points at a sample of fuel to instantly heat and fuse atoms together. However, ignition has been difficult. The goal for nuclear fusion is the break-even point, when we can get more energy out of fusion than we put into it, which we have not yet really achieved. The closest to commercial fusion we have is the ITER project in the south of France, where 35 countries are coming together to build the largest tokamak. Their goal is to produce net energy, or overcome the break-even, maintain fusion for long periods of time, and begin commercial production of fusion-based electricity. The facility is under construction, and experiments are scheduled to start in December 2025. In conclusion, fusion offers a clean, safe, renewable energy source for the world. As we try to replicate the process of the sun on Earth, we may keep running into problems. But this possibility is on the horizon, just barely out of reach. The rewards are amazing and our hope is bright. Keep up to date with this hot topic by visiting www.iter.org.